Alright guys, this is video number 2 on the repair and tips video series, showing you how to do some repairs on these and upgrade your chips or change them to a different color if you need to. So in this video I'm going to talk to you a little bit about why this is happening, and some tips on how to prevent it. If you have a failure and you need to do a repair. So with these cobs, or any LED cob, for example, or any LED at all, there is something called thermal runaway. And what happens is the chips, as they turn on and they get warm, so the heat starts to build up. And that's why we need these heat sinks on the back. So basically, you want to keep your LEDs as cool as possible. The hotter they get, the less efficient they are, and the less lifespan you're going to get out of them. So what that means is the cooler you can keep your chips, the more lumens per watt you're going to get. So it is true that a hotter LED running at the same amount of power will make less light than a chip that's running at the same amount of power that's running cooler. So the byproduct is the heat. So instead of making more light, you're making more heat. So that's the difference. So what's happening here is a lot of these floods have heat sinks that aren't they're not matched very well for the heat load that they have, some of them. And they're not able to dissipate the kind of heat that they're making efficiently enough. So when you first get these things, you throw them on your boat, and they're probably, they're probably going to be real good first impressions. You're going to be like, wow, these are awesome. Well, give them a couple years, and there's a good chance you might run into some problems with the chips burning out or the drivers going bad. So one problem that I see with this light, particularly right offhand, is this is aluminum. It's a cast aluminum heatsink, and it is not anodized. So that's paint on there, like some sort of a powder coat or something like that. And they've painted right over where the chips go. And what that does is it puts a thermal barrier between the chip, just the bottom of the chip, and the actual heat sink. So what you need to do is you need to take the heat from this chip and dump it into the heat sink as efficiently as possible. So what we have is a thermal paste that goes in between the chip and the actual heat sink. And I recommend a good high quality thermal compound like this, or Quicksilver is another one. There's a couple good brands out there that will take the heat and transfer it into the heat sink. So you don't want air gaps between the chip and the heat sink. So that's what that does. It transfers it. And some are better than others. But when you have paint in between the chip and the heat sink, it's not that big of a deal, you might not think, but it has to transfer. All that heat has to transfer through that paint, and it creates a barrier between the chip and the heatsink itself. So what I do when I'm replacing these, this is not the case with anodized heat sinks. Anodized heat sinks, you're good to go, don't need to do anything. With painted ones like this, I sand down to the actual aluminum. and then I apply my thermal compound, so that there's a good contact between the chip, the thermal compound, and the heat sink, and that way you're maximizing the transfer into the heat sink. So what'll happen is when you turn these things on and you run them, the heat sinks will get warm. They could probably get hot to the touch. Well, the chip itself, the temperature of the chip itself is what matters. And if the chip itself gets above its rated thermal load, then what can happen is, again, we'll talk about the thermal runaway. So the temperature goes up, and when the temperature goes up, it draws more amps. So more amps. So the higher the heat goes, the more temperature you have. Sorry, I'm trying to explain this. The hotter the chip gets, the higher the amps go, and the lower the voltage goes. And so, but the higher the amps go, the higher the temperature goes. The higher the temperature goes, the more amps it draws. So you have that's what they call thermal runaway. And what you have with these cobs here, this is a 50 watt cob. If you look closely, you'll see 5 arrays in a string there. So there's actually 1, 2, 3, 4, 5 arrays, and there's 10 chips per array, and usually you're getting 1 watt per chip. So that's how they get their 50 watt cob. So you got 10 chips in series, but then you've got 5 arrays of 10 in parallel. So what that means is if you have one array go out, the other arrays are going to be seeing a higher amp load now. That's the problem with running LEDs in parallel. It's not going to be that big of an issue if your chips are matched very, very closely, but these cheap Chinese cobs, you will not have chips that are matched very close. And that's why when you use a variable DC power supply and you run it into these chips, you'll often see when you turn it down to where it's barely turning on, you'll see there's a lot of chips that don't even turn on, while others are bright. That means the forward voltages are mixed matched, and the chips are not matched very accurately. That's a very, very common thing to see with these Chinese cobs. High quality ones, you'll see all of them turn on very similarly at a very similar voltage. But so what happens is they get hot, the amps go up, make more heat, amps go up more and make more heat, and then eventually one of these arrays blows. And one array blows, all the rest of them are going to blow too, because like I said, this chip is designed to handle around 1.8 amps. So you have to divide that by 5, and that means each array is seeing 1.8 divided by 5 amps. When you have one array blow, now all of a sudden, those amps are going through 4 arrays. And so you've just increased the amp load on each array, and they're already stressed because of thermal runaway, and then the whole chip blows. So that's what happens with these chips. In a nutshell, I hope I did a decent job explaining what's going on there. But let me tell you how to check to see if it's the driver. Here's the driver, by the way, and or if it's the chip that blew. It's going to be either this or this, pretty much, unless you've got a fuse in line that blew. Some of them might have a inline fuse or whatever, and sometimes that'll blow. There can be fuses on the drivers themselves, and if you're handy, you might be able to replace that. But Okay, so what you do is you simply, this applies for DC and AC. So you run 120 volt AC, that's what these drivers are, into, actually doesn't have to be 120. It can be any kind of AC voltage, I think from 85 volt AC all the way up to like 285 volt AC. But standard household, 120 volt AC into the driver. And then you take your meter, take a voltmeter here, and just put it in DC, and then measure the output here. So you're looking for like 25 to 36 volts. Some of them will go up to 40 volts, around there. So you're looking for a good voltage like that coming out of here. I would say probably around 36 to 40 some volts coming out. So if you've got voltage coming out, careful not to cross the wires or short them in any way when you're doing that, obviously. You got voltage coming out of the driver, that's a good indicator that your driver's fine and the chip is bad. You can also verify the chip itself by taking it and hooking it up to a variable DC power supply and simply turning up the voltage until it either turns on or doesn't. Another way to tell, if you really want to check it, if you get it under a microscope, you can see the tiny little gold leads inside. You can almost see it on the video. There's tiny little leads that go from the anode and the cathode. So if you look at those little tiny wires under the microscope, you can actually see that they're melted, blown like a fuse. And that's literally what's happening. These are just blowing like fuses. So that's what I do to tell. I actually use several different methods for testing. I do the voltage test, I do the DC test, and then I actually confirm the damage under the microscope just to make sure that, yup, it's the chip. So yeah, that's the chip. One more tip I want to give you guys. I'm sorry the video is getting long. Actually, I'm just going to close out on this video and we'll just get another one here after I get this chip off and I'm ready to put the new ones in. So, see you in the next video.